Next day I am going to the most important middle of the world city. It's called Mita del Mundo, to do the lot of experiments and see the equator. Now we are in the equator.
Mita del Mundo is just outside of Equator, where the measurements were first made that proved that the shape of the earth is in fact an oblate spheroid. Commemorating this is a large monument that straddles the equator called Mita del Mundo, or middle of the world. The 30-meter tall monument, built between 1979 and 82, was constructed to mark the point where the equator passes through the country in the geodetic datum in use in Ecuador at that time. In the modern datum of the World Geodetic System, which is used in GPS system and computer mapping products like Google Earth, the equator is placed about 240 meters north of the marked line. It was in 1743 that this was first identified by geodesic mission of the French Academy of Sciences, led by Louis Gaudin, Pierre Bouguer, and Charles Marie de la Condamine.
In the center of the world, the great Equator. This place is called Mita del Mundo. In local language, the meaning is that center of the world. This is the equator. So now I am in the southern hemisphere. I am going to stay in the northern hemisphere. This is the equator. Now if you see here, one leg is here, one leg is here. It's really, really beautiful to be here in this place. Now we are exactly on the equator. This shows the latitude 000 here, and the declination of the magnetic is 6.38 degree east. Can you focus there? Zoom out.
See, yes, I do it.
The 0.
Yes.
Beautiful. Now, if you come here, the altitude is 2.483 meters. That is 2.4 kilometers. The altitude from the sea level, and from the longitude from the Greenwich is 78.27.8 seconds. So that is the location of this Ecuador, the place called Mita del Mundo. Thank you very much.
This is the lab and the museum they have in this center, and then this is the sextant, is the instrument they use to measure the angles between the two directions from the mainland, from the ship, using sun, moon and the stars. This is the instrument. They use this old technique, a classical method, and then they found out this equator on the Ecuador. These are the three scientists, French scientists, but today using GPS we found the actual exact equator, which is just 240 meters away from the original one. That means we have to hats off to those scientists. Now we are going to the solar museum to find out the exact equator and also do a lot of testing. This is the entrance of the solar museum, adjacent to the main equator. Here we demonstrate all the Coriolis testings and many more testings in this laboratory.
Now we're going to the equator. Here we have to
boa constrictor. One here is 2 meters long, the big one is 4 meters. They are smaller than anacondas. To imagine how big the anacondas are, you can see there is a skin.
Ooh, oh my god.
Almost 7 meters long. The longest could be 10 meters in Ecuador.
Yeah, have anacondas here?
Because just they saw constellations, and by Pythagoras' theory, the Equators monument, to remember that missions. And here we're gonna be on the GPS line that was calculated by GPS, because 2 days on March 21st and September 23rd, you will be here at noon, your shadow disappear. That's it, at noon. It's because...
Okay.
Okay.
Okay. Actually, this is the 0 degree latitude they found using the satellites, global positioning satellites. This is done just 12 years back. If you see there, you can just turn there. This is done in 1733. 36 by scientists using the ordinary instruments. But if you see the distance, the difference is just at 200 meters, or about 0.7 degrees. Then what an accuracy they have done. We have to hats off to those scientists. They have done long ago. Now we are using satellites, so many satellites, but this is the actual 0 degree. Now I am one leg on the southern hemisphere, and other leg on the northern hemisphere. I am on the exact area. Thank you very much for all these things.
Okay. Here's my hand to remember me.
Thank you.
Special. But they knew where was the north and south with this rock. It's like a compass. Now we have compass to know where is the north, south, east, and west. My question is how people knew, how people did, how they knew where was north and south.
That is, I answered my first question, so others should answer the second question.
Yeah. Okay.
Let us finish in Finland and the first mode.
That's the saucepan.
That's the thing we have been looking for in all the beaches.
Yeah,
because this is the only one I know, and
No,
it looks different in Finland and Sweden if you compare it how it looks in Montanita.
Yeah.
In Montanita you can't see it.
Here.
Montanita I didn't find it.
You didn't find it? And this one, 1, 2, 3, to here, it's called Orion's Belt. Yeah, and here in Ecuador to see constellations first you have to see Orion's Belt, and after that you can see Cloud to see all of them. Yeah, because you are here in the middle, you can see all constellations, especially from March to September when it's no cloud. So they used to represent them like this to know where was the north and south in the day. This moment we are in the south. You have to see the time here from September to March on the position of... But from March to September, the position of the sun is coming to the north. So today is cloudy, but when it's not cloudy, the shadow you can see here in the morning, noon, afternoon. Morning and afternoon, same picture. I'm gonna use my hand to see the shadow there. So look at this. It's almost 1. Right?
It's wrong.
Yeah. I can show you the time, and just in case we have the commercial time 24 hours every day, but the time here is according to the rotation of the Earth. Its rotations is not exactly 24 hours. It is in 23 hours, 56 minutes, and 4 seconds. That's why every 4 years we have a leap year, and the time here must be 10 minutes different. That means less. Okay, 10 minutes. So that theory said that when the Earth is rotating, there are 2 forces. One force is gonna be in the south, another one is gonna be in the north. But 2 forces come back from poles here. They have the same temperatures and they cancel each other out. So they must be like this, straight down, or like this. That's why on the equator it's much easier to balance the egg than your home, because forces are coming straight down. We're going to see the weather tests as well. We're going to see whether it will go straight down, will not be any vortex. And we use raw egg to do the first test. Inside liquid and yolk must be straight down, okay? I'm gonna do first, after that you're gonna try it, you're able to do, I'm going to give you a diploma about this test. That's why I had to try it, okay?
University.
Look at this.
Okay, now please.
You got it. Now it's your time, please.
So you can't do that anywhere else.
Try this egg. Now I'm going to try this egg to put on this. So our guide has done, now it's my turn. Okay? If I'm successful, I'm going to stay back here.
Big one with the egg. Come on, I did it.
Physics?
Yeah, you're not qualified.
You can still see the seashell with the same string, but now you can fail yourself.
Wait till we've all done that.
Get out of my house! Same string, and two. Oh, it's because I was
Okay?
Sí, yes.
Now come here, come here, come here.
On the Equator line,
The
way it goes straight down, but you can see it spinning or wiggling. Okay? Pay attention on the surface.
We are on the equator, right? This is the equatorial line, and then this is the marking we have done. We want you to take the place shape, okay? No rotation.
Oh, yeah.
Right, because we are on the equator, just show here. Now water is stable, and you can just show here.
And your movement, cancel, remember, and
All are going straight.
Straight down.
Ponle así mismo para que él vea que allá, tal como está.
Now, let's go to the south.
See, we have mockery here. We want you to take the same way. The same way. Yeah, okay. I'm taking this.
Eso, mi King, porque si no, no.
So the position is not changed. We kept the position same to make sure that there is no gimmicks here. We want to make sure that Earth is right. That's it.
Only chewing gum.
So
Remember, in the south, the water goes clockwise.
2 hours later, what happened, guys?
Come.
Yeah, I got it.
See.
I'm not.
Let it settle. Let it settle. Let it
Let's
settle.
get the last person back.
Okay, now water is fully settled. Now my friend is going to do this experiment to show how he has to solve southern hemisphere.
Ready? 1, 2, and 3.
Oh!
Okay?
Now, do the spinning.
Yeah,
Clockwise.
clockwise.
In the sun. Okay?
Ya, así mismo ponle
Now,
ya.
let's go to the north.
Okay, we'll maintain this status same and we'll try to do it.
Oh, that's my
Friends, we will do this. Here, we will try. Okay.
Espérate, ve.
Here, we have not changed the position. We kept this place constant. We tried in equator. We tried in the southern hemisphere. Now we are going to do another hemisphere. That means there is no gimmicks in it. We really want to know how it works.
Begin here. Go to the 45 and get back. When they arrive here, the intensity is allowed.
Count clockwise.
Crash with the same temperature.
Now this he's allowing the water to settle now in the equilibrium. Now he's going to do the rest. What's your name?
Gabriel?
Gabriel, okay. Up. The northern hemisphere. Completely right. Counterclockwise.
Count clockwise in the north.
Thank you very much.
Ya, eso, bien.
I'm going to put this.
1, 2, 3, go. Okay, now do your finger like this. I'm gonna try, open your fingers, you have to try to keep close. 1, 2, and 3, go. Harder. There you go. Let's see what happened on the equator. 1, 2, 3, go. Harder. Do this. We do this. Go straight. I wanna try with my pinkies. Let me see. 1, 2, and 3. Only pinkies, alright? So,
Wait.
yeah.
You have to do, I had to hold the eyes.
Yeah,
I had to press.
yeah, push down.
That will be here.
Now let's go to the equator to see.
That's really difficult.
Ready?
Yes, I take a video.
Hold on.
Yeah.
Let me take it.
Higher.
Okay?
Easy.
Easy. Okay.
Try with this.
I think I'm weak anyway.
Your finger like this. Close your eyes and try to walk heel to toe with the eyes closed. It's like alcohol heel to toe. On the equator, it's a little difficult more to do this because I told you the person are coming opposite directions.
It'll put your feet out,
Okay?
Yeah, okay, I got it. Heel to toe slowly. Oh, how much did you drink last night?
I don't drink.
You sure?
I don't eat meat.
We can change that.